This is my programming assignment. I made it for class. This algorithm, and basically what this project does, it calculates the DNA similarity between two different DNA sequences. It compares them and it creates three 2D arrays, and it then traces back through each one, finding the greatest score for that alignment, and then it prints out the alignment in its most optimal form. And you'll find that you'll see two different strings, but this algorithm makes them look very similar, even though they are very different. And some strings just simply aren't compatible, or DNA sequences rather, and you won't get much of a good score. But for the most part, DNA sequences will get at least probably close to, at the minimum, 25%. Here, this is a 2D array being printed out. This is one of the three, and this is just being generated. It's for the traceback of the algorithm to find the most optimal score. And here we see this is actually the strings, and it compares the two. So on the top we have the first one, which I believe is a human DNA. Sequence A is the human DNA, and it is the length of 953. Then at the bottom it is the mouse. And each one of these right here symbolizes that there is a match, and here it symbolizes there is a mismatch if there's a space. Sometimes there's a gap, and that means that the algorithm had to push this string one index further in order to make its most optimal alignment. These are the number of operations I had to use, which are these things I just described, and this is the score of that optimal alignment. Each algorithm will generate a score, and that is kind of just the way to tell how similar they really are. This is done completely in C++, and it is done, I did it in this editor here, and I did all my debugging and programming through this compiler in the command line. Thank you for watching.